Hi, Dr. Shmaila here, your mentor and physiotherapist. Today we continue with chapter number 1, that is Mechanical Principles. Our learning objectives: discuss mechanics of movement including axis and plane and movement of the joints in different axes and planes. Further we discuss planes of movement and gravity. Speed with types, energy, work, momentum, inertia will also be discussed. Friction and its type and role of friction will also be discussed. Now let's start with mechanics of movement. Axis and plane. What is the difference between axis and plane? Basically, an axis is a line and plane is a surface. Now look at the definition. An axis is a line about which movement takes place, and plane is the surface which lies right angle to it and in which movement takes place. There are three axes and three planes. Sagittal axis lies parallel to the sagittal suture of the skull in an anterior posterior direction, and movement around this axis in frontal plane. For example, abduction and adduction and side flexion movements occur in sagittal axis and frontal plane. Further, we look at frontal axis or transverse axis lies parallel to the transverse suture of the skull. Movement about this axis in frontal sagittal plane. For example, flexion and extension, exception of thumb. And vertical axis lies parallel to the line of gravity, and movement about it is in horizontal plane. For example, rotation. Look at this diagram. um, if you pick up a piece of paper in this way and pass a pencil in an anterior posterior direction, then you are basically, this is a sagittal axis, and when you pick up the paper in this way and you pass the pencil or pen in this direction, then it is frontal axis or transverse axis, horizontal. And then if you pick up the piece of paper in this way and pass the pencil in this direction, then it is vertical axis. Now further I explain it with examples. Hands of a watch moving about the central pin and over the watch's face, or a pencil thrust to a sheet of paper and turned to represent the three axes, are convenient example to demonstrate axes and planes. As you know, movement of the body occur at joints. Therefore, axis pass through the joints, and the part moved it is in the plane which lies at right angle to the axis of the movement. Abduction and adduction, except of the thumb, and side flexion movements take place about the sagittal axis and in frontal plane. Flexion and extension, exception of the thumb, about a frontal axis and in sagittal plane, and rotation occurs about a vertical axis and in a horizontal plane. These are all movements. Now look at this picture diagram. This is sagittal plane, or you can say frontal axis. Basically, when you divide the body into two equal halves, right and left, then you see that it is in sagittal plane, and movement you are doing sagittal plane, and movement you are doing in sagittal plane are flexion and extension movements. Now look at this figure. When you further, if you we cut the body from head side, and then we divide the our body in anterior and posterior direction, like front is um, uh, this is all region, front side, abdomen including abdomen, legs, etc., and posterior region is your back in posterior side. Okay, basically this represents frontal plane, and this is frontal plane, and movement that are occurring in the, are abduction and adduction in a sagittal axis. Now look at this. This is basically horizontal plane, and the movement that you are performing in horizontal plane are medial and lateral rotation of arm, shoulder or leg. Dimensions of movements. Zero dimension means point. One dimension means line. Two dimension means plane. And three dimension means cube or sphere. These are basic terminology for understanding. Well, now we discuss plane of movement and gravity. There are three planes of movement and gravity. Movement in the horizontal plane. Movement in the horizontal plane is in no way affected by the gravity, and we can say it is gravity free. Weak muscles which are unable to produce movement against gravity can often succeed in doing so when the part moved is supported horizontally. For example, when you are in lying position, spine lying position, and you are lying in couch or plinth, then your whole back spine is supported horizontally and gravity effect is eliminated, and this movement is basically you are performing exercise in this plane are gravity free. Movement in the inclined plane. Movement in this case can be up the incline or downward. Incline mean like when you go hill areas uphill and then you come down towards from the hill. When muscle work to produce movement up the incline, the resistance offered to them by the force of gravity is modified and reduced by the reaction of the plane. Reaction of the plane is greatest when the incline is nearly horizontal. Therefore, the resistance to the muscle is reached when the incline is nearly horizontal. When the incline approaches horizontal, then we can say that our muscle exert least power. So, resistance to the muscle is least because reaction of the plane is maximum and increases as it approaches vertical. Movement uh, downward is produced by the force of gravity. As you look, when you come down from a hill or slope, then you come easily without any effort, because it is the force of gravity that is exerting and that forcing you to go down. The magnitude of his force increases as the inclination approaches the vertical and direction of the plane decreases. Now look at movement in the vertical plane. Upward movement is produced by the force such as that of muscle contraction which exceeds the force of gravity, and downward movement is produced by the force of gravity and occurs at a specific speed which can be modified and controlled by the muscle action. Now, what is speed? Speed is the rate at which a body moves, and it takes, as you know, no account of direction. For example, a car has a speed of 40 miles an hour. Speed is uniform if the car travels the same distance during every second that it moves, but if it slows down at a turning and then increases speed along a straight road to make up for lost time, speed is, then we can say speed is variable, but the average speed for a given time can be calculated. No, speed, there is a speed of relaxed passive movement. Speed at which a passive movement is performed must be slow and uniform so that relaxation can be maintained. Speed of active exercises, there is a natural speed for every exercise which varies to some extent for each individual, and in general this is the speed at which exercise should be done. The effect of many exercises can be modified, however, by alteration in the speed of their performance. Reduce speed. Exercise done more slowly requires greater muscular effort and so will require more control. Decrease in the speed of the repeated movement and show time for full range movement. Increase speed. Rapid movement also requires strong muscular effort, but the momentum is gained, and this may help to increase the range of joint movement. If you increase the speed, provided that direction is not reversed before the free limit is reached. Exercise performed rapidly are stimulating but frequently lead to inaccurate or trick movements, and full range movement is rarely achieved. Let's take the example. For example, if you are assessing a patient with shoulder pain and his shoulder he's restricted, his active range of movements are limited, then uh, he or she uses a trick to show you that his shoulder is elevating, but actually he or she is using his scapular muscles to elevate the arm. Velocity, as you know, velocity not only the rate of motion but also the direction. For example, an aeroplane travels at 500 miles an hour. An easterly direction, a change in either speed or direction is said to alter the velocity. Work. Work is defined as the product of force and distance to which the force acts. It is measured in joules and ergs. Energy. Energy is the capacity of the body for doing work. Further divided in two types. Potential energy is the capacity for doing work by virtue of position, and body's capacity for doing work because of its velocity is called kinetic energy. No, power. Power is the rate of doing work or rate of energy expenditure. It is measured in joules per second or ergs per second. These are basic definitions, and you already have learned them in physics, FSC physics. What is acceleration? Acceleration is the rate of change of velocity. A positive acceleration causes an increase, and deceleration or retardation or decrease in the velocity. Galileo dropped heavy bodies from the leaning tower of the Pisa and established the fact that all bodies, irrespective of their weight, are subject to the same uniform acceleration as they fall freely under gravity. This is called movement under gravity. Momentum. Momentum of body is the quantity of the motion it possesses, and it is represented by the product of mass and velocity. The force responsible for the momentum will generate movement slowly in a relatively heavy body and more rapidly in a lighter body. Inertia. Inertia is the resistance of a body to any change in its state of rest or motion. A body at rest tends to remain at rest indefinitely, while a moving body tends to continue moving at a constant speed and in a straight line unless acted upon by a force. A railway truck in a goods yard requires considerable force to start it moving, but once it gets going, it continues until another force, such as collision with the buffers of another truck, impedes it. If there was a man standing in the first truck, he would be thrown at the moment of the collision, and as his body would continue moving on into basically inertia. This is inertia. That means it is basically resistance of a body to any change in a state of rest or motion. If the body is at rest, it tends to remain at rest, while if a body moving body continue moving at a constant speed unless a force acted upon it, and then it will stop. Friction. What is friction? Friction is the force which opposes motion when one surface slides upon another. It may be sufficient to prevent movement altogether, as in the case of rough surfaces or substances such as rubber when they are in contact with one another. The frictional resistance obtaining during dynamic friction is slightly less than the so-called limiting friction, that is, the friction obtaining just as sliding is about to set in. You can say um, types of friction are dynamic and static friction. Dynamic friction during movement and limiting friction or static friction. Friction obtained just as sliding is about setting. Dynamic friction may be further reduced during movement of a limb, while the limb remains supported by a plane surface, usually a polished surface such as table or a plane on which the limb will slide. The use of talcum powder or oil on the sporting surface will further reduce the friction and make the movement easier, where the suspension of the part to be moved virtually eliminates all the frictional resistance. Obviously, when you suspend the part, then it is hanging loosely, and so all friction basically eliminates. The increase of friction plays an important role in safety measures such as non-slip floors in gymnasia, slopes, stairs, non-slip footwear, rubber pads, or on walking airs. If you take the example, crutches, stakes, frames, rubber pads are rubber-like and attach on these walking airs on on their under surface that are touching the ground. Okay, thank you. That is all.